Well, thanks for joining us at the Daily Space Weather Show. The story of the day is solar flares. We'll start out with those wavelengths here at the SDO. 94 angstroms bringing it to you. Once again from the Smash News Network, least busted name in news. I'm your host, Dan, a.k.a. Smash-O-Mash. That's a 24-hour video. 94 angstroms from Solar Dynamics Observatory. Ionized iron. 2 X-class flares on that video. I believe one is from sunspot 3664 in your lower center picture, and one is from 3663 in your upper right. Here's a little closer view as we get closer to the equator. And closer to solar maximum. We also do have some new flare-producing regions that are yet to show themselves on the Earth's side of the solar disk. That increases the likelihood of a large solar flare at the eastern limb. We already are seeing some flares there. And interestingly, the background X-ray flux for the past 24 hours has exceeded M-class. So you have to include the flares in the background flux. And that brings the background flux up to something like an M1.5. Is the background X-ray flux. It is the highest background X-ray flux we've seen throughout solar cycle 25. Here's a close-up of sunspot 3664. And we hope you're viewing this on a 90-inch TV or something like that. Of course, part of the reason why we started to make these videos in the first place is because back then, about pushing 6 years ago, I had a really small, junky, old, outdated computer monitor. And I wanted these images projected onto a larger screen. Here's sunspot 3663. It still remains our TMAS, or most active sunspot. As it gets closer and closer to the limits, likelihood of producing an X-class flare only goes up. Exciting stuff for space weather, and we'll show some more imagery here in just a moment. Before we do any of that, how about a 48-hour video from SDO? There's our 131 angstroms wavelength, another spectacular wavelength to show solar flaring activity. And yeah, not too bad. It's exciting stuff. Also, we've got at least 2, possibly as many as 3 more coronal mass ejections headed in Earth's direction. So the one that we talked about yesterday, not included into this. So there's could be as many as 4 on the way, but at least 3 as we speak. And this one, once again, we see a disparity between NOAA and NASA, which we'll get to momentarily. Now, today we're doing a cosmic ray report as well, so let's do that next. We're going to crisscross the world and show the cosmic ray monitors here in Antarctica and all around the planet. So we'll show about 7 different cosmic ray monitors. First, the Antarctican DOMB. DOMB Antarctica there, showing a modest downtick for the past 30 days in cosmic ray flux. DOMC Antarctica, almost flat there, just a hair down at DOMC. Moving way up north to the land of Finland, Oulu, Finland, showing a mild uptick in cosmic ray flux there. That's the Oulu neutron monitor, one that goes all the way back to 1964. And let's go much farther south to Mexico City. Mexico City, a tiny downtick there at Mexico City for the past 30 days. Athens, Greece, not sure, but it's flat for the past, 20 of the last 30 days. Last but not least, Apatity in Barentsburg. So check it out. We just had a big spike there at Apatity. A big transient uptick there at the Apatity neutron monitor. Look at that. A big spike there. Just coming through today, actually. Which brings Apatity up quite a bit over the past 30 days. Barentsburg, quite the opposite. Not only a downtick in cosmic ray flux, but a significant downtick for the past 30 days. So mostly flat there for our neutron monitors. Let's take a look at what's going on planet Earth. And the Iceland volcanoes are still erupting, although quite mildly. So that's a real-time imagery there from Iceland, from the webcams of Iceland. And yeah, there's indications that there is still pressure on those magma chambers, just not expecting any major upticks. The seismic activity beneath them has been fairly mild. So yeah, the Reykjanes Peninsula continues to erupt, but probably simmering down at this point. No major upticks indicated on the Reykjanes Peninsula. Subanose Jima is also erupting here. Unknown volcanic ash plume there. Mount Ibu exploding, 10,000-foot ash plume over Ibu. Luatobi, Dakono exploding, 8,000-foot ash plume. Ruang, 6,000-foot ash plume as it explodes. Kilauea, showing some uplift at the Halema Uma'u lava lake. I want to know what's going on at Pu'u'o'o. Pu'u'o'o. Yeah, but sulfur dioxide levels remain low at Kilauea. Popocatépetl exploding, as usual. Sancho Guido, volcanic ash not observed, could be cloudy, could be erupting. Fuego's erupting in an explosive fashion, 15,000-foot ash plume there. Nevado del Ruiz, report received from Vona Sangay, producing a 21,000-foot ash plume. Revenador, 14,000-footer. And Sabancaya, the world's tallest ash plume-producing volcano. 25,000-foot ash plume there. Flight level 250 over Sabancaya. Please do not pole vault the caldera of it or of Ubinas. Over the past 90 days, there are earthquakes. And over the past 24 hours, we did have one 6+ magnitude event. It was at Vanuatu. We'll call it out. These are the quakes of a 5 and greater magnitude for the past 24 hours. West Chilean Rise had a 5.0. It was at depth. 10 kilometers. Never mind. At the surface. Vanuatu had a 6.1 at 8:17 this morning. It was near the surface. Chile had a 5.2. It was at depth over 100 kilometers. That was at 10 o'clock this morning. Then Vanuatu had an aftershock at 11:51. And those are the 5 and greater magnitude quakes. 10.7 centimeter radial flux now at 204 solar flux units. And before we get to more of that, let's take a look at some more fresh 24-hour imagery of the closest star. So yeah, sunspot 3664 there on your southern central screen. That is quite a magnetically complex sunspot. In fact, it probably has more magnetic shear than 3663. It's just not in such close proximity to the limb as 3663, which is in your upper right. At least 2 or 3 more active regions about to rise there in the east, as you can clearly see. We also have some massive prominentiary filaments, including a crown prominence at the southern polar region, which we'll also get to here. Don't forget to show 304 angstroms. And there is an SDO roll maneuver that's happening there. That's causing a little bit of signal bumping. Some imagery bumping around there. That is the SDO doing a roll maneuver for whatever reason. And you may also see a CME happening right in here. If you watch this area, right at the end of the video, right in there, you'll see a CME popping off right where that arrow is pointed. And there it goes. Or should I say, here it comes, because it may be another earthly directed CME. If I had to guess, I'd say 70-30% chance that it will have another Earth-directed component. So exciting stuff going on when it comes to space weather, and we're always delighted to bring you the world's most comprehensive daily space weather content. Again, the radio flux all the way up to 204 solar flux units. There it is, depicted in a 1-year graph conveniently to contextualize the radio flux. It's proportional to sunspot number. So when you see a high sunspot number, you typically see a high radio flux. And really, this one is just a result of major activity on those sunspots. It's not because of an uptick in sunspots. In fact, we've seen sunspot number come down with the radio flux coming up. So we can expect the radio flux to drop into tomorrow, most likely. But that's the current situation. 204 solar flux units is the radio flux. Space Weather Enthusiast dashboard here isn't forecasting any geomagnetic storms or geomagnetic unrest, but they are showing on the NOAA Enlil spiral. It's the same organization. The Space Weather Prediction Center is NOAA, the National Oceanic and Atmospheric Administration. And there you can see a CME impact now on the forecast for late in the day on the 10th into early in the day on the 11th. So that's new. And as far as ESA looks like it needs to update because it's only showing one little spike there. And yes, we pressed refresh. That's looking outdated. We'll get to why here later in the video when we talk coronal mass ejections. First, we'll talk about Earth's geospace and what's going on there. There are the past 4 hours of Earth's magnetic moment from space. The geospace magnetosphere movie here depicts Earth's magnetic moment in magnetohydrodynamic pressure for the past 4 hours. Things are chill at the moment with 3 and possibly 4 CMEs headed this way. So here's our ground magnetic perturbations map. Today we're showing just North America. And the most likely place to see the aurora right now is in the normal places where you'd expect to see the aurora. Nothing spectacular going on for that. KP index is at 2. KP2 is the geomagnetically calm condition we currently see at planet Earth. And out at Lagrange point 1, there are the ACES measurements. 463 kilometers per second at 2.5 protons per cubic centimeter. Discover's measurements vastly different as normal. About 480 kilometers per second for the solar wind velocity, solar wind density here, just over 7 protons per cubic centimeter. GOES magnetometers are calm. We're seeing fairly smooth curves there because, well, no geomagnetic storms have struck recently, but they're coming. And one of them might be a major one. It is quite directly headed toward Earth. Again, we'll get to that in a moment. First, magnetic sectors. There is a South Pole magnetic sector headed this way. It's still probably about 2 to 3 days out. 2 to 3 days out, I'll say. We've got some South Pole-oriented coronal holes here rotating in that are just popping up over the horizon, which we'll show you here. But first, our line-of-sight field plot. Earth remains in a North Pole magnetic sector. Line-of-sight field plot here. So good. So good. It's a reason to really enjoy the National Solar Observatory because that is a fantastic 4-day series of images to show you a lot about what's going on with the closest star, El Sol, Helios, the local yellow dwarf. So, here is our line-of-sight coronal hole plot, and you'll see a little bit of red popping up there over the eastern limb. Those are those South Pole-oriented coronal holes that we were talking about. And let's move on to the 211 angstroms wavelength. Ah, very nice, very nice. So the coronal hole uptick continues as we forecasted for, frankly, a couple of years. Solar Cycle 25 has featured quite a shortage of coronal holes, which brings us to sunspots. I guess those are kind of important, right? Sunspot number here dropping down just above 150. It looks like about 152 sunspots is the current number. And depends on how many sunspots we see rise. That could be fairly flat moving into tomorrow. Sunspot 3663 in the northwestern limb won't be uncounted for over 24 hours. So by tomorrow's Daily Space Weather video, 3663 will still be in the sunspot count. It depends on if we see new regions rise or form between now and then, if we see the number go up or down. So basically a flat report, a flat forecast for sunspot number. As you can see here, a very high likelihood of large solar flares, especially from sunspot 3664. I would argue with this a little bit in that I think 3663 is still more likely to produce large flares. But as 3664 gains complexity and moves closer to the limb, it will, in the next 36 hours, become the most likely the T-mass, or most active sunspot. Next, we'll look at sunspots here in splentacularly awesome detail. So there's our SDO continuum. Here's our magnetogram. And wait till you see the close-ups. The close-ups today are bonkers. Just a delight. There's 3663. And there is still quite a bit of magnetic shear there. Also, those sunspots are not symmetrical. So if you look at the leading main fields, they're quite different than the trailing fields. That's a good thing if you want to see solar flares. When you see a beta-class sunspot group and the sets of umbra and their fields are very symmetrical to each other, that tends to be a more stable sunspot. This is a less stable or more volatile sunspot. And it's been a big performer. A fine example of you don't need a large sunspot to see large flares. It's all about the magnetic field complexity and magnetic shear. And we're going to show you magnetic shear in some splentacular detail here next when we look more closely at sunspot 3664. 3664 is a classic major flare-producing sunspot. And the likelihood of that has been going up. Yeah, that depicts 24 hours at 30 frames per second. And wait till you see the magnetogram of this thing. It is full of deltas. So when you see areas that are completely white with areas that are completely black right side by side, those are deltas. So yeah, that is a nearly 100. That is a greater than 50% chance of producing a major flare. I'll say greater than 80% chance of producing a major flare. That sunspot is definitely not done with the fireworks. Speaking of fireworks, let's cover that next. Flares and energetic particles. So the ghost proton flux here, much more likely to see a spike in it with this outgoing sunspot 3663 there in the upper right, the northwestern limb, sunspot 3663, becoming more and more likely to produce an SEP. And also 3664 is becoming more likely to produce an SEP, as these are most likely to be produced at the western limb. So anyway, here's our X-ray flux, and like I said, the past day, the background flux is over an M class. It's probably something around here, like about an M1.2. Flaring is definitely going to be the story to cover. So here is, once again, 94 angstroms from SDO. And no end in sight to the flare production. Next, we'll move on to CMEs. Those are kind of important, but first, some more chill stuff, like a forecast for the solar system. Don't you want to know what's going to be going on overhead? Happy New Moon, by the way. It is New Moon Day today, May 8th. That's where things will be in a week on the 15th. We'll be just reaching first quarter by the 16th. This is our star chart from skyandtelescope.org. I like to use it. And check it out, folks. Oh my God. The moon, the Pleiades, and Jupiter are all nearby in the sky, which you should be spooked of because reasons. Pardon my sarcasm. Moving on to our astronomy picture of the day, which is not a picture at all. It is an artist's rendition of the massive radio source, sometimes referred to as a black hole. We talked about them yesterday briefly. And for some reason, it does not want to be full screen. Anyway, it's talking about the way light is bent. It's a way to explain gravitational lensing. And if you think gravitational lensing is too controversial to cover on the channel, make sure you leave a rage comment. Leave your rage comment and tell us why gravitational lensing is fake, or why space is fake, or why that's CGI. That's definitely CGI, by the way. That's, again, an artist's rendition. Is light bent by massive radio sources such as galactic cores? Yeah, there's certainly something going on there, as we can clearly see. You know, light from a galaxy that's behind that galaxy, projected in front of that galaxy, an indication that the light's being bent by some feature. All right, so CMEs are next, and you're going to see multiple halo eruptions. So you'll see, really it's 3. It's actually 3 that you can see on that image, and there's another one that's happening as we make the video. So there's one on the way, 3 in this imagery, and another one. So there's actually going to be 4 on the way. Because of the 4 that are occurring today, one of them is not earthly directed. So the first one is actually on the far side of the sun. So we've slowed this. We've stopped this here at 5:36 for the LASCO C2. So that first halo eruption is from a far side event, but right around the same time is an Earth side event. So there's actually 2 things going on there almost at once, and then another halo CME. And then again, there's another one happening right now. So this is actually 2 right here. And then a second one there, just after midday Universal Time today. Now there's another one that's popping off as we make the video, which it's too early to really cover that too much. But there's 2, there's 3. And again, there is another one happening as we make the video. We'll also show Stereo A, which we've paused around 8:30 Universal Time for the raw imagery, and around 7:30 for the difference imagery. So there you'll see this double event, and then a second event around midday. So very consistent there. And let's move on to our custom coronagraphs. But first, let's show, well, wait a minute, why are we showing filaments? All right, let's zoom in. We'll zoom in close first. We'll go back through if we have to. So again, the first event that happens here is on the far side, but right around that same time, an Earth side event occurs as well. So it looks like as many as 3 of 4 coronal mass ejections that have occurred today are earthly directed. Now the last one came from up here, so that one's a little bit too early to say, but again, if I had to guess, I'd say that may have an earthly directed component. I'm going to say actually 70-30, maybe even 80-20. So here if we zoom out, you'll see multiple events. The first one is not associated with any plasma motions on this side of the solar disk, but the second one is, and it came from right in here, the southeastern portion of sunspot 3664. And as we zoom out further and further, you will see that I'm not whistling Dixie, whatever that means. I'm not pulling your chain. I'm not talking smack. I'm talking facts. Multiple more CMEs headed in Earth's direction. Now the ones from today, they're going to start arriving late in the day on the 10th. Possibly even as early as midday on the 10th. So, yeah. I'm going to say something like midday on the 10th. Expect to see CMEs start to show up. By the way, these videos come from helioviewer.org if you want to check that out. And let's kind of go back here. We'll show the origin point of those CMEs. When it resets, so there's one on the far side and then one right here and then a third right here. Well, it might be 2 from the far side, so let's see. I think the one from midday might be also earthly directed. So fingers crossed for that. That is some spectacular imagery. Anyway, let's move on to filaments. And man, oh man, filaments. we got some major filaments kicking off. So if we look at the Cerro Tololo ground-based hydrogen alpha telescope, this one that's just launching as we make the video is this one up here. Still multiple filaments on the Earth side of the disk. And here are the prominences that I talked about earlier. Major Charles Barkley prominence down there in your lower right. That would be the southwestern limb. There's also a crown prominence at the southern polar region and multiple new active regions rising in the east. Here are the past couple of hours, and you can see that CME popping off as we make the video. From right up here, likelihood of X-class flares is something like 80%. So, great stuff for space weather. And by the way, did you know that you can expect cosmic ray flux to continue to tick down for the next about 17 months? Yeah, 17 months. Cosmic ray flux, it lags solar activity by like 5 months. So you can expect about 10 months of increased solar activity, or levels at least as high as we have now, and then another 5 months, so 15 months. 15 months of continued decreases in cosmic ray flux. So if anybody's telling you that energy from space is increasing, maybe solar irradiation, solar irradiance is going to be increasing for about 5 months when we reach solar maximum. But as far as energy from space is increasing, if somebody says energy from space, just tune them out. They've said absolutely nothing. They've been so vague. They might as well tell you that you march to the beat of your own drummer. Ooh. Flip my tarot cards, please, forecaster. So here come bonus features, starting out with satellite charging hazards. We have some minor ones here of the surface charging variety over southern Asia. Electron flux here coming up off the floor as forecasted by NOAA and by our channel yesterday. There's the one-year graph to contextualize the relativistic electrons measured at the F layer of the ionosphere. And there's NOAA's forecast, which is similar to ours, although I guess we underestimated a little bit. I said I agreed yesterday with NOAA's forecast. I still agree with NOAA's forecast until CMEs start to arrive tomorrow night. Starting tomorrow night. So there's that. Also, we've got the F layer of the ionosphere. We show it daily on the channel. You never know when you'll see an anomaly in the data that you weren't expecting or realizing had predictive value. But there is the ionosphere and its vibrational frequency. Megahertz. It's the ionosonde. And if you're wondering what my shirt says, it says words that cannot be uttered. It says words that cannot be uttered. However, if you visit the links below the video, you'll find a Redbubble shop in order of best selling. This product was our best seller for like 2 years. So there's the ionosonde. And if that's Greek to you, don't worry. Here's the anomaly in megahertz from a 30-day median. And as we forecasted yesterday, you'll see a lot more blue, a lot more high-frequency anomalies there, and a lot more white, non-anomalies, as the ionosphere slowly reaches static equilibrium. So that's what's going on at about 300 kilometers of altitude. Here is our global ionosphere nowcast. And some major GPS errors happening over the Pacific Ocean, for example. Also the Indian Ocean seeing some major GPS errors. Also the Atlantic Ocean seeing some major GPS errors. Like around midnight local time. So that's total electron content and maximum usable frequency. Here's our latest imagery. Getting some artifacts there on the magnetogram as we see some new regions rising. So there's a new sunspot. Some new umbrae forming behind that alpha class sunspot group there. That'll probably be another group as well. And we see some more organized magnetic fields popping up down here. So far only a plage, but that's the scenario, which brings us to meteorology. Meteorology, it's a value-added service that we show on the channel because, well, meteorology is just too easy to forecast. So we throw it in because a lot of people don't seem to have any clue what they're talking about when it comes to weather. So here we go. The world's stormiest seas are located down here adjacent to Antarctica in the Southern Ocean. Only 30-foot waves right now, which means overall there is no disaster. There is no oceanic disaster in the form of large waves for us to bring you today. So pardon us for all you catastrophists who want to see wanton destruction. Today we ain't got none. Those are the surface winds and significant wave heights of planet Earth. Here are the wind patterns. Surface winds of the east. Shout out to our viewers from under and from over the equator on this side of the planet. There are the jet streams of the central world. Surface winds of the central world. Strong onshore wind at Portugal. Doesn't make for good waves, folks. You want an offshore wind to stand those waves up. Make them taller and steeper for better drop-ins. Here are the surface winds of the western world. And there are the jet streams. Doubled up jet stream over North America at the moment. And here is our satellite imagery. Ah, how sweet it is. Not half bad. The NASA GOES Interactive Weather Satellite Suite Visible Satellite is spectacular. Next, our windy.com map, and we've centered the map here on the hot air capital of the world, Colorado. Check it out. In Aspen, they've got 50 inches of snow remaining on May 8th. Here is our snow depth map for the U.S. And dag, there is a lot of snow remaining in Montana, Wyoming, Colorado, Idaho, California, Oregon, and indeed Washington. Should be a pretty epic melt season as it continues to fall in some locations. So here's our weather.gov map. Weather.gov is the National Weather Service homepage. We've got some severe weather in the central part of the country, both sides of the Mississippi Valley. Massive tornado watches, severe thunderstorm warnings, and indeed some tornado warnings, which those don't happen unless tornadoes are spotted. That's not from a funnel cloud. That's from a touchdown. A touchdown of a funnel cloud on the ground. That's when it becomes a tornado. So anyway, there you go. Some heavy flooding in the forecast there as well. We did have some strong storms move across places like Tennessee and Kentucky. We'll get to it. First, the 72-hour GFS pressure and precipitation forecast. That's what's going on. More heavy snows come out of the hot air capital of the world. And there it is. There's the snow depth change forecast in inches for the same period. GFS 72 hour is the model. Dag. Total accumulated precip is next, also in inches. Heaviest rains coming to Iowa, Kentucky, Tennessee, Louisiana, Texas, Indiana, and Illinois. Last but not least, temperature anomaly forecast in degrees Celsius as a cold snap makes its way to Pennsylvania for the rest of the week. And indeed, the beginning part of the weekend. It's going to be cold. Cold and possibly dreary in the mid-Atlantic states. Pacific Northwest will have quite the opposite, with some extremely hot temperatures there. Something like 16 degrees Celsius, that's in Celsius, above normal during part of that forecast. Next, lightning. And like I said, we saw some strong storms move across Kentucky and Tennessee. Also the Midwest. Points now east of the Mississippi Valley are in the crosshairs for some severe weather. So here is our line of of lightning. Massachusetts getting some thunderstorm activity. Also the Carolinas, but the main storms here are the strongest ones were just south of St. Louis there, moving to the east. So that is the kind of storm that can be accompanied by damaging wind and hail, and of course, tornadoes. So there may be one here moving east north of Carbondale. Again, weather.gov is where to get your weather warnings. Weather.gov, the National Weather Service homepage. We'll close out the video with Doppler radar and satellite imagery for the lower 48. There's a full 50-state view. There's a lower 48 view. And a series of highly concentrated storms with very high cloud tops showing up there, all the way from Missouri to North Carolina. And they're moving east-northeast. It'll be more obvious on the satellite imagery and indeed the water vapor map. So there is the visible satellite, just splentacular. And there is the water vapor. Here's the recap. Hopefully you're able to forecast your own weather. Whether it's weather in space, whether it's weather in space, or whether it's weather on Earth. Doppler radar, visible satellite, water vapor, and me abandoning this operation and heading back to the bunker. Back to the bunker, folks. Back to the bunker. Because there's nothing safer than hiding in a bunker from space weather. Pardon the sarcasm, but we'll see you next time. And in the meantime, may that solar wind be at your back. Bombs away. Whoa!